Welcome back. In this chapter, we're going to talk more about solving equations, and this time using some other little techniques to help solve our problems and other different kinds of equations as well. In this section, we'll start off by talking about solving by factoring, and sometimes it's not always obvious that factoring is the way to go. If I'm looking at this first equation here, x minus 1 to the power of 2/3 equals to 4, it might not occur to me to think about factoring, but if I'm thinking about rewriting it first, x minus 1 to the 2/3 minus 4 equals to 0, I know that 4 is a perfect square. It's 2 times 2, but also x minus 1 to the 2/3 is a perfect square. Notice that if you were to take x minus 1 to the third and then square it, you would get x minus 1 to the 2/3. So actually, what we really have going on here is a difference of squares. If I rewrite it as x minus 1 to the 2/3 minus 4 equals to 0, then there's two squares there. It's x minus 1 to the third that's being squared, and 2 that's being squared. Just going to make that look a little bit nicer. So as a difference of squares, we have x minus 1 to the 1/3 minus 2, and we have x minus 1 to the 1/3 plus 2, and that's equal to 0. And then the only thing that we need to do after that is to solve for x. And that's easy enough for us to do. I'm just going to add another page here. Okay, so from this, we have two factors multiplied together equal to 0. So that means that either we can say that x minus 1 to the third minus 2 is equal to 0, or x minus 1 to the third plus 2 is equal to 0. And of course, power of a third, that's cube root. So really what we're saying is cube root of x minus 1 minus 2 is equal to 0, or cube root of x minus 1 plus 2 is equal to 0. And now from this point on, it's fairly straightforward to solve. I'll bring the 2 to the other side. To get rid of the cube root, I'm going to cube both sides of my equation. So cube root and cubing undo each other, so that'll leave me with just x minus 1 on the left side, and on the right side I'll be left with 2 cubed, which is 8. So I'll have one solution that I find, which happens to be 9. And if I do the same thing with the other side, bringing the 2 to the other side, cubing both sides to get rid of that cube root, I'll have x minus 1 again on the left side, and on the right side negative 2 cubed, which is negative 8. So I'll wind up with x being negative 7. So my solution set contains 2 points, or 2 values rather, 9 and negative 7. And if you want to go back and check your solutions, you can find that yes, indeed, both of these do satisfy the original equation. All right, moving on. Another one here. This one, your first instinct might be to take what's on the left side, expand it out, and then bring the 9x to the other side and start to simplify. But actually, one thing we might notice here is, if I brought everybody to one side, actually factoring can happen, a common factor can happen, because now I'll have two terms, and in both terms x will be a factor. So I'll have x minus 3 squared left over in the first term, and I'll have minus 9 left over in the next term. Now, if you're feeling particularly clever at this point, you may be noticing that inside the bracket that we have here, we have a difference of squares. X minus 3 squared, that's obviously a perfect square, and 9 is also a perfect square. It's 3 squared. So if we're using our identity, the difference of squares, we'll have x minus 3 minus 3 and x minus 3 plus 3. So we'll wind up with x times x minus 6 times another x equal to 0. And so now we can get some solutions out of this. X is 0. X minus 6 is 0. Or in other words, x is 6. And the third solution is the same as the first. X is 0. So for our solution set, we only have two solutions, really. 0 and 6. We don't need to list 0 twice, even though it shows up as a solution twice to this equation. In solution sets, we only list each solution once. So even if it shows up more than once, we only list it once in our solution set. Now, another kind of equation that we'll be interested in working on are radical equations. Those are equations which contain a radical, a root. And so the idea here is that we're going to square both sides in order to get rid of roots, but with a little bit of carefulness, a little bit of paying attention to what we're doing. So I say squaring both sides because for the most part we'll be talking about square roots, but of course if it was cube roots, you'd cube both sides, or if it was fourth roots, you would raise both sides to a power of 4. Now, before we start doing this with our equation, we would want to first rewrite it so that there's only one root on one of the sides of the equation, so that we've got a root isolated, so that when we square both sides or cube both sides or raise both sides to whatever power we need to, it'll get rid of that root. Now, the other side of the equation might have some extra roots still lying around, in which case we're just going to repeat that process, isolate the radical, and then raise both sides to a power, simplify, and if there's no more roots, then we can continue solving by whatever other method now applies. Now, there is one important thing to note here, and this is a pretty big caution. If we are squaring both sides or raising both sides to a power of 4 or 6, any even power, that can wind up introducing what are called extraneous solutions. These are values of x that do not satisfy the original solution. And so the important thing here is if we're ever solving a radical equation, and if at any point you ever wind up squaring both sides or raising both sides to a power of 4 or any other even power, you must check your solutions. So I said at the very beginning of the course that there will be some times where you'll have to check your solutions, where it will be mandatory, and this is one of those times. If you're raising both sides to an even power, then you must check your solutions. If you're raising both sides to an odd power, you won't get extraneous solutions that way. You can certainly check your solutions if you want to, but it's not required. It is required in the case, though, of even roots, when we're squaring both sides or raising both sides to powers of 4 or 6 or any other even power. So let's start with this one, a nice first one to begin with. And I'll begin by first isolating my root. So I'll put that 2x on the other side. And now, since it's a square root that I would like to simplify, or like to get rid of rather, then I'm going to square both sides of the equation. And that means that on the left side, square root then squared, the square root will be gone. I'll be left with 10 minus 3x. And on the right side, 2x being squared, 2 squared is 4, and x squared is x squared. So now we've got ourselves a nice little quadratic equation. 4x squared minus, plus 3x minus 10. Now at this point, you can solve however you'd like. You can solve it by factoring. You can solve it by using the quadratic formula. Either way that you do it, you will come up with two solutions to this. You will find that x is equal to -2, and you'll also find that x is equal to 5/4. Now, you might feel tempted to just stop here and state your solutions. But again, since we squared both sides, since at this step we squared both sides, that means that we must check both of these solutions to find out, do they satisfy the original equation? So that's my next move now. Before I start stating my solutions, I'm going to need to check them first. I'm going to need to check to find out, does it satisfy left side and right side when x is -2? What about when x is 5/4? So I'll start with checking x being -2. So with this one, the right side is always just 0 here, so nothing really to calculate for us. The question is the left side also going to be equal to 0? And if I put in -2 for x, I'll have root of 10 minus 3 times -2. And then -2 times -2. If I were to simplify this, inside of my square root, I'd have 16. I'd have a root of 16 plus 4, which is 4 plus 4, and that would be 8. So left side and the right side are not equal to each other, which means that I have to reject that solution. Because, as it turns out, even though we found a solution of x being -2, x being -2 doesn't satisfy the original equation. So, too bad for us, that's one solution that is not going to be part of our solution set. Now, you can't just assume that the other solution will be a part of the solution set. It's possible for some of these radical equations where both the solutions you find wind up being solutions of the original equation. It might turn out that everything you find is extraneous. So we can't just assume that since one of them was extraneous that the other one isn't. We have to check and find out. So we'll need to look at x being 5/4 and find out, does that satisfy the original equation as well. So now we'll move on and check the 5/4. And again, the right side is already equal to 0, so I don't really have to do anything with that. The left side I'll need to check, and I'll find out what happens when I put in 5/4 for x. So I'm going to just use my calculator's fraction button to simplify what's inside of my square root. 10 minus 3 times 5, fraction button 4. I'd find that that is, as an improper fraction, 25/4. And for -2 times 5/4, that's, using my calculator, -5/2. And now, just to simplify, square root of 25/4, that's square root of 25, which is 5, over square root of 4, which is 2. So the left side actually does simplify out to 0. So left side and right side are equal to each other, which means that 5/4 is a solution. So therefore, our solution set only has one value in it, and it's the value 5/4. Okay, let's do another one. This one, we're looking at cube root of 3x plus 1 plus 2 equals to 0. And I'll start off with first isolating my radical, bringing that 2 to the other side to make it -2. And at this point, I will get rid of my cube root by cubing both sides. So that on the left side, I'll be left with 3x plus 1. And on the right side, I'll have -2 cubed, which is -8. And now I just need to solve for x. And I find the value of x is -3. Now, you certainly can check your solution if you'd like to, but you're not required to in this case. We didn't raise things to an even power, we raised things to an odd power. Odd powers won't be giving us extraneous solutions. It's only when we raise things to even powers that it's possible for us to get extraneous solutions. So I feel confident enough to stop here, but I think it's a good exercise for you to go back and check this solution and just justify specify that yes, -3 is a solution to this. It does satisfy the original equation. So I'll leave my solution set as containing just the value -3. One more. And this one is a little bit more involved because there's not just one root, there's two of them, or two radicals for us to deal with. So you can choose however you'd like, but the first move that we're going to have to do is to bring one of the two radicals over to the right side. We want to have one side of the equation that just has a root on it. I'm going to make the choice to bring that negative root of x plus 3 over to the other side. So on the left side, 2 plus root of x minus 7, that's what I'll have there. And on the right side, root of x plus 3 is what I'll have there. Now, I'm going to mention one thing before I do any simplifying. When we're squaring this, remember, what we're doing is squaring not the individual terms. That would be wrong. No, thank you. That's not what we're doing. What we're doing is squaring both sides of the equation. So the left side is being squared and the right side is being squared. The right side being squared is nice enough. That's just going to get rid of our square root. That's x plus 3. But what we can't forget is that when we square the left side, what we're really doing is taking 2 plus root of x minus 7 and multiplying it by 2 plus root of x minus 7. This isn't going to be just the same thing as first thing squared plus second thing squared. We're going to have 2 times 2, 2 times the root times 2, the root times the root, which means that the left side of the equation, when we multiply it out and collect like terms, we will have 4. We'll have 2 times the root plus another 2 times the root, or 4 times root of x minus 7. We'll have the root times itself. Root of x minus 7 times root of x minus 7 just gives me x minus 7. And now I'm going to simplify by, again, getting the root by itself. So I'll bring the 4, the x, the 7 all to the other side. And when I do, on the left side I'll have 4 root of x minus 7. And on the right side, all I'll have will just be 6. The x's will cancel, and when I bring the 4 and the negative 7 over to the other side, it leaves me with 6. Okay, so to isolate this root, I'm going to divide both sides by 4. And when I divide both sides by 4, then I'll have just the root on the left side, and on the right side 6/4, which is same thing as 3/2. And I'm going to square both sides again. That's our idea. We isolate a radical, square both sides. If there's still roots left around, isolate it again, square both sides, and just keep going until there are no more roots left. Now, one thing that I just want to mention before we go any further is notice we've squared both sides. We did it again. That's 2 warnings to us that we will still need to check our solutions no matter what we find, whether we find one solution, 2, 3, or whatever. We'll have to check because there is the possibility that they might be extraneous. So we're going to now continue on. The root has been squared and the right side has been squared, and that means on the left side, root of x minus 7 when I square it leaves me with x minus 7, and on the right side, 3/2 when I square it leaves me with 9/4. And then bringing the 7 to the other side, we'll have 7 plus 9/4. Using my fraction button, 7 plus 9 fraction 4, and then equals, and that will give me a mixed number. Second function, fraction button, that will give me my answer as an improper fraction, 37/4. Now, only thing that we need to do is check our solution, and away we go. We still need to check, even though we only found one solution, because it's possible that even though we found one value for x, it might be an extraneous solution. So for the left side, we're going to need to put in 37/4 in for all those x's. So left side is 2 minus root of x plus 3 plus root of x minus 7. Use your calculator to simplify what's inside those square roots. Root of 37 fourths plus 3. If 37 fourths plus 3 is 49 fourths. 37 fourths minus 7, that would be 9 fourths. And now, root of 49 fourths, that's root of 49 over root of 4, or 7 over 2. Root of 9 quarters, that's root of 9, which is 3, over root of 4, which is 2. And this does equal to 0, which happens to be what we have on the right side. So yes, left side is equal to the right side. We can feel confident in now stating that the solution set contains one value and one value only, and that value happens to be 37 fourths.